Multiplying radicals. It's pretty much the same as multiplying monomials. So if you can get this concept, 6x times 4x, you can get this concept. What does 6x times 4x equal?
24x squared.
Good. That's it, Jonathan. Excellent. You do the 6 times 4 to get 24, and the x times x to get x squared. So I'm doing the same concept here. The numbers outside get multiplied together, and the numbers inside get multiplied together. So 2 times 6 is 12, and 5 times 4 is 20.
You don't have to have the same inside now?
What was your
When you're at, it's the same as with like terms. I can multiply 6x times 4x squared, right? Even though those aren't like terms. But I can't add 6x and 4x squared, right?
So it's easier to multiply because you don't have to do all the work.
I don't know that it's easier, but I mean, you can multiply anything. You can only add or subtract like radicals, right?
Like it's easier to multiply fractions.
Yes, that's definitely true. Yes.
What would you write in the paragraph, or if anything?
I wouldn't write anything, just write the example. So this is not finished. What do I need to do?
You can simplify the
Factor 20 and see if I can pull something out. 2 times 10, 2 times 5, 5's prime. So I can. There's a pair of 2's. So what does that make the number on the outside?
24.
Good. And the number on the inside is
4.
good.
So all you do is multiply the 2 outside, the 2 inside, and then see if you can simplify.
That's it.
And that's the easiest thing.
Now, in a minute, we're going to have to, this is just a monomial times a monomial. But in a minute, we're going to have to distribute and also FOIL. But the process is the same, right? Does anybody need more time with this?
Are we going to telephone?
No, not today.
Oh.
I'm going to work a few examples like this, then I'll show you how to use the conjugate, and then I'm going to go over 11 and 12 from the homework, and that should be the rest of our time. Anybody need more time now?
well, I don't.
Yes. Tell me when you got it, Chris. Yep, you're multiplying the numbers that are outside together, and you're multiplying the numbers that are inside together, and then always checking to see if you can simplify. You got it? Okay, so now we're looking at some more complicated examples. Let me move this out of the way because I'm going to need some room. So on this example, what I'm doing is I'm going to be foiling. Because this is 2 terms times 2 terms. When we have that, we FOIL. So it's just like foiling was before. First, outer, inner, last. So when I multiply 2 times the square root of 3 times the square root of 10, I multiply the 2 times the understood 1, and I get a 2 on the outside.
Times the square root of 30, right?
Exactly. On the inside, it's 3 times 10, and that's the square root of 30. Good take. Then when I multiply 2 times the square root of 3 times 4 times the square root of 6, the 2 and the 4 get multiplied to give me 8, and the 3 and the 6 get multiplied to give me 18. Good. Then I would do negative square root of 5 times the square root of 10. So it's a negative times a positive, so it's definitely going to be negative.
Negative square root of 50.
Good. Negative square root of 50. And then here, negative 1 times the 4 is a minus 4. And the 5 times the 6 on the inside gives me the square root of 30. But I'm not done. Because you can already tell these are like terms, or like radicals rather, and they can be combined. But I should also try and simplify, right? See if I can simplify any of these radicals. Let's see if we can simplify 30. Let's just try it.
Why don't you go ahead and like put those 2 together? And
You could totally do that. You could put them together and then simplify first. But I'm going to try and simplify first. So 2 times 15, 3 times 5. So can I simplify 30, square root of 30?
No.
No, I don't have any pairs, right? There's no pair of numbers for me to circle. So I will go ahead and combine those, and I would get negative 2 times the square root of 30. Okay, now let's deal with these. 18. That's 2 times 9. 9 is 3 times 3, and 3 is prime. That one simplifies. I get to pull out a 3 times the 8 that's already there to give me 24. And what's on the inside? 2. Okay, let's do 50. 2 times 25, 5 times 5, 5's prime. So I do get to pull out a 5, times the -1 that was there gives me -5 times the square root of what? 2 again. And so now these are like terms. So 24 square roots of 2 minus 5 square roots of 2, 19 times the square root of 2. And that's all I can do. Does that make sense?
Yes, sir.
Okay. I'm only going to do one more like this, and then we'll switch over to the conjugates. I'm not going to change it or anything. Can you still see everything you need to see? Okay. I just wanted to make some room so I could work another one. So this problem is actually easier, but I do want to do one like it, just so I can say that we've done one like all the ones on the homework. So this is not a FOIL problem. What do I need to do here?
Distribute.
Just distribute, right? So 1 times 2 on the outside is 2, and 5 times 10,
Square root 50.
excellent. 1 times 3,
3.
square root of 5 times square root of 2,
10.
square root of 10. Now I would want to simplify if possible. And I can, because this has a pair of 5s. So I pull out the 5,
And you put back the 2.
and I multiply that times the 2 that's here to give me 10.
My bad.
And that's no problem. And I put back the 2. And then 10, I could try it, but I know that 10 is just 2 times 5. So there's nothing to pull out there. So this is it. These can't be combined. That's as simplified as it gets. Other questions about these?
No, sir.
Okay. We'll get more experience with the multiplying when we do the conjugates. That's why I feel okay skipping these last two, because I'm going to do more multiplying when we do conjugates.
Did you not cut hair, Lucky?
I don't know how to cut anybody's hair. You would not want me cutting your hair.
That's now on video.
I can shave it.
No.
No.
Might
Uh,
get cut, but he can get it.
All right. So conjugates. Here's conjugates. So the conjugate. You know, we had the definition yesterday.
Yes, sir.
The conjugate of an expression like 4 minus the square root of 3 is the exact same expression except the sign is different. So 4 plus the square root of 3 would be the conjugate. In order to rationalize the denominator, if it has plus or minus in it like this does, I have to use the conjugate. I can't do what we would normally do. Normally we would say, okay, well, I want to get rid of the square root of 3, so I need to multiply by the square root of 3. But I think you'll see pretty quickly what the problem is if I do that. If I do that, on the top, I get 4 times the square root of 3. Don't write this down, because this is me working it wrong to prove a point, okay? I'll work it correctly in a minute. And then, hold on one second, Amber. And then down here I would distribute. 4 times the square root of 3 would give me 4 times the square root of 3. And negative square root of 3 times square root of 3 would give me negative 3. I haven't cured my problem, because I still have a square root of 3 on the bottom. So multiplying by the conjugate will cure the problem. What's your question, Amber?
Just a curiosity, wouldn't you subtract 4 minus 1, and then it'd be 3?
So I can't do that. But for the same reason that I can't do 4 minus 1x and say that that's 3x, right? These aren't like terms, so I
Oh, because
can't.
it'd
What
be
if you multiply by the reciprocal?
So it's kind of like that, but multiplying by the reciprocal would change this, right? The reason why I'm allowed to multiply by the thing I normally multiply by is because it equals 1. This does not equal 1, right? In order to be 1, it has to be the same thing on top and bottom. And so if I multiply by the reciprocal, I'm actually going to be changing the problem. But here's what I multiply by. The conjugate, which is the exact same as this, except whatever sign is here, I use the opposite. So this one was a minus, so mine is a plus. On the top and on the bottom. This is okay to do because it's the same on the top and the bottom, so it equals 1. I'm really multiplying by 1.
Are you subtracting or multiplying that?
I am multiplying. Sorry, it does kind of look like maybe it might be a minus. That's a multiplication dot. Now, on the top, I distribute. This gets multiplied by both of these things. On the bottom, what do I do on the bottom?
FOIL.
I FOIL, right? So let's see what happens. Let's see why this works. On the top, 4 times 4 is 16. What is 4 times the square root of 3 equal?
4 times the square root.
That's what it equals. There's nothing else I can do. 4 times the square root of 3 just equals 4 times the square root of 3. The same way if I asked you what does 4 times x equal, you'd say
4x.
4x. I mean, that's just all you can do, right? Now, on the bottom, I'm foiling, which means I'm going to start off by getting 4 terms. First, outer, inner, last. There's going to be 4 things. So if I do first, I do 4 times 4 and I get
16.
16. So that was first. Then I would do outside, so that would be 4 times the square root of 3,
Which is 40 squared.
which is 4 times the square root of 3. Then I would do the inside, so that's negative square root of 3 times 4. So I know it's a negative times a positive, it's got to be negative. And 4 times the square root of 3 is just 4 times the square root of 3 again. Then I would do, oh my gosh. This is not hard. I think you're letting it blow your mind, but it shouldn't.
It's still homework.
Mhm.
Oh, darn.
Those
Square
two
root-
cancel each other out.
The negative, yes, I'm going to get to that in a second. Very good, Aaron. Negative square root of 3 times positive square root of 3. It's a negative times a positive, so it's got to be negative. That should not blow anybody's mind. And the square root of 3 times the square root of 3 equals what?
3.
Just 3. Now, you'll notice what's happened. What's happened is my first term and my last term have no square roots in them. None. That should happen every time you do this. Whatever you get here, there should not be a square root. If there's a square root here or a square root here, you did it wrong. What else should happen every time is what Aaron pointed out a minute ago. What happens with the 2 in the middle?
They cancel.
They cancel. 4 square roots of 3, take away 4 square roots of 3 is no square roots of 3. They're gone. So that should happen every time as well. These 2 should cancel. So the only square roots I had on the bottom are now gone. They canceled. And I would combine these like terms and I would get 16 plus 4 times the square root of 3 all over.
13.
Yes, ma'am.
In this particular problem, those two 16s would cancel each other out.
They would not.
Why?
I will show you in a minute.
That's what I was
I
thinking.
don't have time to get into it here, but that doesn't work because this 16 is part of an expression. It's for the same reason.
Okay.
So I'll try and briefly explain.
But like I get that the only reason why that happened is because there was a 4 on the top and 4 on the bottom. But like, I
So-
thought that
so-
basic,
So by your same logic, I should be able to cancel these 5s out, right?
Oh, no.
yes.
Okay, I should be able to do that, and then I would get 5 over 1, so this would equal 5.
Yeah.
But that's not what it equals. Because 5 plus 5 on the top is what?
10.
And 5 plus 1 on the bottom is what?
6.
Does 10 divided by 6 equal 5? No, so you can't do that. You can't cancel like that if you have a binomial. If you have more than one term, that doesn't work.
Okay.
Now, if I just had the 5 on the bottom and not the plus 1, then I would be able to simplify some. So we'll talk about the simplifying in a minute.
The bottom fraction down, man.
Say what?
The bottom of that fraction, where you got the x's in.
Yes?
They're down.
Here?
From where you just pointed out and said this,
Yes?
from there down.
To here.
Yes, I'm confused.
Okay.
Those
Do you know how I got this?
Not really.
I foiled.
Okay.
Let me work another example, okay, before we run out of time. And if it still doesn't make sense, I'll answer the questions then. So, on this one, in order to simplify, I need to multiply by the conjugate. The conjugate is exactly what's on the bottom, except the sign is going to be the opposite. Multiply the top and the bottom. Since I'm multiplying by the same thing on the top and the bottom, I'm really just multiplying by 1, so I'm not changing anything. On the top,
You just distribute.
you distribute. 2 times 3 gives me 6. And 2 times negative square root of 5 is,
Negative 2 the square root of 5.
there's nothing else I can do. I cannot multiply the 2 and the 5 because one's inside and one's not. On the bottom, I have a binomial times a binomial. That means to FOIL every time. So first, outer, inner, last. 3 times 3, that's
9.
first, that's 9. 3 times the negative square root of 5.
Say it out loud, Joe.
I don't know.
So think of it this way. 3 times negative 1, what does that give me?
Negative 3 times the square root.
No square root thing times the square root thing, I just keep what's in that one, right? So 3 times the negative square root of 5 is negative 3 times the square root of 5. For the same reason that 3 times negative x equals negative 3x, right? And it's the same concept going on there. I see a lot of people that look like their minds are being blown right now.
That's good.
I've got a
Okay, I'm gonna, hold on one second, let me finish this problem, and then I'll take all the questions that I have time for. I think you're letting all of the square roots in the problem intimidate you. This is foiling. You guys are good at that. You can do this. This is not hard. You're making it hard in your mind, but it's not. Square root of 5 times 3. That's the same as saying x times 3. What's x times 3?
38.
So what's square root of 5 times 3?
3
3 square root of 5. It's the same thing. It's the same concept. Square root of 5 times the negative square root of 5. Well, first off, I know it's a positive times a negative, so this is definitely going to be
-5.
negative. And square root of 5 times the square root of 5 just equals 5.
And then those two middle ones can cancel out.
Good. So what I said was going to happen every time happened. These on the ends have no square roots in them. And the two in the middle are exactly the same, except they have opposite signs, which makes them cancel. Let me finish, and then I'll take all the questions.
It's actually, yeah, but since 9 minus and then the 5 is negative, when you turn that to a plus is the
No, because
negative.
the minus isn't with the 9.
The minus is with
Where
the
do I have a
three.
minus minus?
Yeah, I mean,
She
The
thinks
nine
that
is
it's 9
positive.
minus -5.
yeah.
That's what she was thinking.
Front of that
So
3.
you cancel it out.
There?
Yeah.
The minus minus has to be right next to each other to do the plus plus thing. So, shh, these two go together, and these two go together. The top is just what it is. On the bottom, -3 times the square root of 5 and +3 times the square root of 5 equals 0. So they cancel. And 9 minus 5 is 4. This is not finished though. This is the one last thing you have to check for. Look at all of the numbers that are outside of the radical sign. Aren't they all divisible by
Yeah.
something?
2.
So I should divide them all by 2. 6 divided by 2 is 3. -2 divided by 2 is -1. And 4 divided by 2 is 2. That's the final answer. Okay. Yes.
I'm looking at the homework,
Mhm.
and on number 11, both of the numbers on the bottom have.
Are in square roots.
Yeah.
Doesn't affect it. I'm about to work number 11 right now. So go ahead and get out the homework.
And if the whole entire problem is like a negative, then when you do
Talking about on number 11 where it's got the
the
negative?
conjugate with that
So
problem,
I'll-
then become a problem.
I'll show you how to handle that too.
Do you want to record this, Mr. Vincent?
Yeah, I'll record it. So this is still running, right? Still going?
Yeah.
Okay, so here's the first thing I would do. They put the negative in the middle. I don't really like that. Remember the negative in the middle, it doesn't matter. I can put it with the top number. So I'm just going to rewrite the problem really quick so the negative is next to the 2. This is the same thing. And now it's really easy to manage that negative. I need to multiply by the conjugate. The conjugate is exactly this, except the plus is a minus.
Why'd you look at me?
I wasn't looking at you, I was just looking in that general direction. Okay, on the top, I would distribute. -2 times the square root of 3 is just -2 times the square root of 3. You can't put them together. One's in the radical and one's not. -2 times negative square root of 5, well, it's a negative times a negative. We're all comfortable with those sign rules, I hope. So that definitely means positive. Negative times negative is positive. 2 times the square root of 5. I can't multiply the 2 and the 5 because one's in the square root and one is not. Bless you. On the bottom, I am going to FOIL. Square root of 3 times the square root of 3 just equals 3, right? Because it would be the square root of 9. 3 times 3 would be 9, and that would be under the radical, but the square root of 9 is just 3. Then I would have the square root of 3 times negative square root of 15. These numbers I can multiply together, because they're both
Square root
on...
of 15.
That's it. So, did I say 15?
Yes, sir.
Well, that's what it's going to be, right? I'm a step ahead of myself in my brain. So the square root of 3 times the negative square root of 5.
You confused me.
It's a positive times a negative, so it's definitely negative. And they're both under the radical, so they can be multiplied together, and I get the square root of 15. Then I would have square root of 5 times square root of 3, that equals positive square root of 15. Those matched, and they're opposite signs, just like I said they should. Then the last thing, square root of 5 times a negative square root of 5.
Negative 5.
Negative 5. Notice, First term, last term, no square root. Middle two terms, same thing but opposite signs so that they'll cancel. This should happen every time. So these do cancel. And the top is going to be the same for now. And 3 minus 5 is negative 2. But I can simplify this. So negative 2 divided by negative 2 is 1. So that just ends up being the square root of 3. And positive 2 divided by negative 2 is negative 1. So that just ends up being negative square root of 5. And that's it. These things are the same. On any of these problems with simplifying radicals, you can always check it relatively easily in the calculator. You can punch the original problem in the calculator, and you can punch that in the calculator, and it should give you the same thing. And if it does, you're right. And if it doesn't, you're wrong.
Are you gonna work 12 then?
Yep. I got just enough time. I got to work kind of fast. I'm sorry, because I want to have time to pass out the homework.
Hey,
Yes.
did you just scroll down?
Yes. Can I do what?
Can you go back to that one and like scroll down? All right.
Okay, you need to write quick, because I'm going to run out of time.
Can you just write it on the chalkboard? We'll make the thing.
I'll start passing it. You got it?
Never mind.
All right, 12.
Actually, it's 25, but that's where it is 25.
So, multiply by the conjugate. On the top, you distribute. 2 times the square root of 5 is 2 times the square root of 5. 2 times 4, 8. On the bottom, you FOIL. Square root of 5 times square root of 5 just equals 5. Square root of 5 times 4 equals 4 square root of 5. Negative 4 times the square root of 5 equals negative 4 square root of 5. And negative 4 times 4 equals negative 16. The two in the middle match but are opposite, so they cancel. Keep the top as it is for now. Do 5 minus 16. That's negative 11. And there's no number that goes into 2, 8, and 11, so there's no way for me to simplify this. And that's it. That's all I can do. All right, here comes tonight's homework.
Turn in your homework, guys.
If you are 100% complete, like you've done every single